Photoelectric effect. So what is meant by photoelectric effect? Right, sir. So this is a metal, right? When the light of sufficient energy, the light of sufficient energy incident on the metal surface, the electrons will be ejected out. That phenomena is called as photoelectric effect. Okay, when this is the phenomenon of emission of electrons from the surface of the metal, right? When electromagnetic radiation of suitable wavelength or suitable frequency or suitable energy fall on it is called as photoelectric effect. So whatever the electrons emitted from the metal surface are called as photoelectrons. The current produced due to that photoelectrons are called photoelectric current. Clear, sir? So when the light energy, when the electromagnetic radiation or light energy of sufficient light energy. So why I am putting the condition there? So we will discuss the later on. So when the light of sufficient frequency and the light of sufficient wavelength incident on the metal surface, the electrons will be ejected or emitted out from the surface. That phenomena is known as photoelectric effect, and the electrons emitted from the metal surface are called photoelectrons. Okay, and the corresponding current is called photocurrent. So the materials in the periodic table, the first group elements lithium, sodium, potassium, rubidium, cesium, francium. First group element, 1A group, right, sir? So here last element is the radioactive element. You neglect that one. Remaining metals, lithium, sodium, potassium, rubidium, cesium. So these are called alkali metals. The first group metals are called alkali metals. So they can exhibit the photoelectric effect with visible light. So when the visible light is allowed to fall on these metals, we can observe that photoelectric phenomenon. But the materials like zinc, magnesium, cadmium, so they can show this photoelectric phenomena with ultraviolet radiations only. Okay, so visible light, if it incident on the zinc metal, you cannot observe the photoelectric effect. The visible light is incident on the magnesium or cadmium metals, you cannot observe. The electrons cannot be emitted out. Only they can exhibit, they can show the photoelectric effect with ultraviolet radiations. But whereas the alkali metals can show this phenomenon with visible light too. Okay, so visible light wavelength already explained you 4,000 to 7,500 angstrom. Right, ultraviolet less than 4,000. Violet, so violet కంటే తక్కువ ఉంటుంది. నీకు అల్ట్రావైలెట్ వేవ్ లెంత్ violet కంటే తక్కువ ఉంటుంది. వేవ్ లెంత్ తక్కువ అంటే ఫ్రీక్వెన్సీ ఎక్కువ, ఫ్రీక్వెన్సీ ఎక్కువ అంటే ఫోటాన్ ఎనర్జీ ఎక్కువ. రైట్ సార్? అంటే ఎక్కువ ఫ్రీక్వెన్సీ ఉన్న ఆ లైట్ పడితేనే సో జింక్, మెగ్నీషియం, కాడ్మియం మెటీరియల్స్ ఫోటోఎలక్ట్రిక్ ఎఫెక్ట్ ని ఎగ్జిబిట్ చేస్తాయి. కానీ విజిబుల్ లైట్ ఆ మెటల్స్ మీద పడ్డప్పుడు మీకు ఆ ఎనర్జీ సరిపోదు. లోపల ఉన్న మెటల్ సర్ఫేస్ లో ఉన్న ఎలక్ట్రాన్ ని బయటికి తీయడానికి, టు రిమూవ్ ద ఎలక్ట్రాన్ ఫ్రమ్ ద మెటల్ సర్ఫేస్ ఎనర్జీ ఇస్ నాట్ సఫిషియంట్. Therefore, electrons cannot be emitted out from the metal. So you have to observe that one. So one more point is, this photoelectric effect was discovered by first in 1886 Hallmarks, and which was confirmed by Leonard in 1889. So the theoretical explanation of photoelectric effect was given by Einstein. Hertz was first to verify this effect experimentally. Okay, sir. Einstein explained the photoelectric effect by using the Planck's quantum theory. By means of Planck's quantum theory, he explained the photoelectric effect and derived the equation. That equation is called Einstein photoelectric equation. So theoretical explanation was given by Einstein. Experimentally, this was verified by the Hertz first time. Right, sir? So the more experiments, experimentally, in 1900, Leonard studied this photoelectric phenomenon in detail. So regarding that, the experimental setup is shown in this box. You observe this one. So let us describe this diagram, sir. So this is cylindrical shaped glass tube, is evacuated glass tube. It consists of two electrodes. One is P, another is C, right? So two electrodes, one electrode is P, this is cathode. Another electrode is C, this is also called as collector. P is connected to this high tension battery, and C also connected to the high tension battery through microammeter between cathode and anode. So this is the cathode, this is the anode. So between the cathode and collector, so there is a voltmeter. Voltmeter is also connected in parallel. What is the purpose of voltmeter? Voltmeter measures the potential difference between these two electrodes. What is the use of microammeter? Microammeter measures the photocurrent, which is constituted by the photoelectrons. Right, sir? So here high tension battery in the midpoint is grounded. It is earthed. So with this arrangement, we can maintain this collector at a negative potential or positive potential. So we can maintain a desired negative potential or positive potential. So this the use of this high tension battery and arrangement purpose is that one, right, sir? So it also, you can observe one more. S is a quartz window. So from there, the light is allowed to incident on the metal surface. In general, this cathode is taken the alkali metal. Alkali metal, lithium, sodium, potassium, rubidium, cesium, and so on. So this cathode is made up of alkali metal. When the visible light is allowed to fall through this quartz window on this metal surface or cathode, so because of the photoelectric phenomenon, electrons will be ejected. So, but here the collector is relatively, it is connected to the high potential. This collector or anode, it is connected to some positive potential. Compared to the cathode, it is at high potential. So therefore, these electrons will move towards the plate. These electrons will move towards the collector. Therefore, the circuit is closed here. Hence, the current flows because of these electrons. This current is called photocurrent. That photocurrent we can measure by means of this microammeter. And whatever the potential difference we are applied between the cathode and anode or cathode and collector, that can be measured by the voltmeter. Followed, sir? Have you followed the description of this diagram? Clear, sir?
Yes, sir.
Yes. Now, when the light is incident on the cathode or alkali metal, so because of this phenomena, electrons are emitting. These emitted electrons are moving towards the collector, right, sir? Now, so here, this anode or collector is also maintained at negative potential. But of course, compared to the cathode, it is at a high potential. For example, it is -10. It is negative electron -10. It may be -5. So -5 greater than the -10. The cathode it is at -20. It may be -5. Then also it is higher value, right, sir? So then, even though there is a negative polarity for the collector electrode, the electron, some number of electrons will move towards the collector. So therefore, we are observing the deflection in the microammeter, or we are observing the photocurrent. When you increase the negative potential of this collector, when you increase the negative polarity of this collector, okay, so -5 to -6, -7, -8, -10, like that. At a particular negative potential, even the single electron cannot reach this collector. Then the deflection in the microammeter becomes